Right, hello, all you math geniuses out there. So, we are actually going to be talking about what I believe is our last factoring lesson of the year today. All right, and we are looking at factoring cubics. So, hopefully, you've at least heard that word before. So, whenever you hear cube, that refers to 3. Okay, so let's talk about what a perfect cube is. 1 would be a perfect cube because 1 is the same thing as 1 times 1 times 1. Okay? 8 would be a perfect cube because 8 is the same thing as 2 times 2 times 2. So hopefully you're seeing a pattern here. Okay? 27 is a perfect cube because 27 is the same thing as 3 times 3 times 3. Another way to say that would be that the cube root of 27 is 3. Okay? A couple more common ones. 64 is 4 times 4 times 4. 125 is 5 times 5 times 5. Okay? 216 is 6 times 6 times 6. Sorry about that, I just realized what that says. 343 is the same thing as 7 times 7 times 7. And another really common one for you to see, you're not going to see 8 and 9 very often. You will sometimes see 10 cubed. So 1,000 is 10 times 10 times 10. So those are the ones that you really need to be familiar with. There are definitely others. Those are the most common ones to see. Okay? So let's talk about what I do when I see these numbers in equations. Okay? So for example A, I notice I've got an x cubed here, so that should make some bells go off in my head that I'm dealing with cubics. I also notice I have a 125. Well, if you go look at the list we just made, 125 is a perfect cube. Okay? So here's what I want you to think about. Whenever we are factoring things, we are always breaking them apart. But this time I'm trying to break apart something with 3 pieces, and I can't break that evenly in half. So here's what happens when you factor a cubic. You get a little parentheses, and then you get a big parentheses. So the big parentheses is going to get more than the little, again, because I can't divide 3 things evenly in half. Okay? So here's what happens when I factor. I say, okay, I've got 3 x's here. I've got to break them apart. The way that I do that is to say, well, the little parentheses gets one of those 3 x's. The big parentheses gets the other 2. Okay? Then I go and I look at the 125 and I say 125 is the same thing as 5 times 5 times 5. So my little parentheses is going to get one of those 5's. The big parentheses is going to get the other 2 5's. So 5 times 5 is 25. Okay? This last piece is just something that you kind of have to memorize. There's a big gap right here that I need to fill in. What I fill it in with is whatever's in this little parentheses. So I have an x and a 5, so I fill in a 5x here in the middle. Again, that's just something you kind of have to memorize. Okay? The very last thing that you have to memorize is because this is a difference of cubes. Okay, you've got a minus sign. You're going to get 3 signs. They're always going to go minus, plus, plus. So there's my pattern right there. If it's a difference of cubes, I do minus, plus, plus. Okay? There are my factors right there. You can try to factor this some more right here, but what you find out is there isn't anything that multiplies to 25 and also adds to 5. So right there, I am done factoring. Okay? I'm going to hold off on the solving for just a minute. I'm going to go ahead and go to example B and show you how to factor that one. So again, I notice I've got a cubic. I've got an x cubed, and 8 is also a perfect cube. I can't split 3 things evenly in half. So when I draw out my parentheses for my factors, I've got a little one, and I've also got a big one. Okay? Then I start to split this thing apart. I've got 3 x's. Can't split those in half evenly. So what I can say is that the little parentheses gets 1x, and the big parentheses gets 2 x's. I go and I look at the 8. 8 is the same thing as 2 times 2 times 2, so 3 2's. The little parentheses is going to get one of those 2's. The big parentheses is going to get the other 2 2's, okay? So 2 times 2 is 4. Here's the part again that I just have to memorize. The way I fill in this big gap here is I take whatever's in that little parentheses, so 2 and x, and I write it down. Okay. Here's the part that is somewhat different from what you did on the difference of cubes. You have a sum of cubes. You started with a plus sign. The only thing that changes about my factoring is now my signs go plus, minus, plus. So there's my pattern every time. Okay? So here's what I would like for you to do. I would like for you to stop this video right now, flip over to the practice, and just factor all of those questions. Okay? We'll get to solving here in just a minute, but make sure that you can factor all of those, then come back and watch the solving. So hopefully you took my advice and went and factored everything on your practice sheet first, okay? Now I'm going to show you what to do to solve after you've factored, okay? We are looking for where this equation equals 0. So sort of like what I did in the last 2 days, I'm going to take each piece and look for where it equals 0. Well, the first piece on this one is easy. Where does x minus 5 equal 0? Well, that happens when x is positive 5. So there's one of my answers right there, done. The second part is tricky because I can't factor it any farther. So we're going to pull back out something that you've seen quite a while ago, and that is your quadratic formula, okay? So if you need to write this down, your quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, there's my quadratic formula. That's what I'm going to do here on this second piece. So the first thing I have is opposite b. Well, b is positive 5. The opposite of that is negative 5. Okay, plus or minus square root of b squared, so 5 squared. Notice how I put that in parentheses there just around the 5. Minus 4ac. C is 25. All over 2 times A. There's my quadratic formula. Okay? Once I get here, I'm not going to type the whole thing in my calculator. The only thing I'm going to type in is all of this under the square root. And if you type all of that in, it tells you that it is negative 75. That should set off warning bells in your head, because if I have a negative inside of a square root, I know right off the bat, hey, that's imaginary. Okay? I am almost done. The only thing I haven't done yet is I have not taken that square root of 75 and simplified it. Okay? So I take that 75 and I'm going to kind of come over here to the side. And if you need to write over in this box, you're welcome to do so. I'm going to make myself a little tree. And I say, okay, what goes into 75? Well, there's a couple different things I can do. I know that 3 and 25 works. Okay. Then I say, okay, how can I split up 25? Well, 25 is the same thing as 5 and 5. So right there, I get a pair of numbers that gets to come outside the square root. So when I go back to my answer now, I am not changing the negative 5 or the 2. That hasn't changed. The only thing that has changed is now instead of writing a 75, I get to pull something out of it. I get to write the 5 on the outside, and that lonely little 3 stays inside. Okay? Once I get right there, I do have to check and see if I can reduce anything, but if I look at 5, 5, and 2, there is nothing that goes into all 3 of those numbers. So right there, I am done. Okay? So just to remind you of your steps. Step 1, you factor. You got a little parentheses and a big parentheses. If I want to actually solve, I look at where each piece equals 0. The first one will always be really easy. The second piece, I'm going to have to do the quadratic formula, and I'm probably going to get a really ugly answer, but that's okay. Okay? So go ahead, get started on today's practice. Hopefully you've already done the factoring. Now go back and solve these.